Alright, so I think this is recording. We're looking at solving triangles and we're using the law of sines and law of cosines to do it. In this problem, I'm going to have to use the law of cosines. I know that because I'm not given a pair. I have the measure of angle A, but I'm not given the length of A. So I'm going to use the law of cosines. And the first thing I'm going to find is the length A. So I go to my reference sheet and I know that A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. And since I'm wanting A and not A squared, I'll take the square root of each side. So that now I'm ready to substitute in and use my calculator and get this length for you. Alright, so we're going to replace B with 9.51. Don't forget to square it. We're going to replace C with 6.37 and square it. Subtract 2 times this product of these two values and the cosine of this obtuse angle. Now remember, if a triangle does have an obtuse angle, it has only one, because the three angles have to add up to 180. So you can't have two angles that are both bigger than 90 plus 90 is 180. If both angles were bigger than 90, it would add up to something more than 180, and it can't do that. So let's take the cosine of 147.2. Alright, so let's go to the calculator. Let's double check. I'm in degrees. I've got it fixed to 2 decimals, and that appears to be fine. So let's key in the square root, and now just try to not make keystroke errors, which I have done in previous videos if you've watched very many of these. The 9.51 in one of the previous videos, it was like 2.9, and I keyed it in as 29. So, you know, those are mistakes that I sometimes make, and I try to double check, but an accident is an accident. Do your best to try to eliminate those silly type of mistakes. Alright, so I'm getting 15.26. Alright, so now I have a known pair. I know angle A and I know the length of A, so I can jump to the law of sines and to find another angle measure, either angle B or angle C. And since this angle A was obtuse, it doesn't matter which of the two I use. You want to, if you're finding an angle and using the law of sines, you want to avoid taking the inverse sine of an obtuse angle, because that inverse sine is only going to return a value that's in quadrant 1 that's an acute angle, and you'll have a mistake. But I don't have to worry about that. The obtuse angle is already known. So let's find the length of B. And I can either use the law of cosines or use the law of sines. Cosines or sines, it doesn't matter. The sine of angle B, well, that's what I'm actually trying to find. I need to pay attention to what I'm doing. I'm trying to find the angle B, because I already know the length B. It was given, 9.51. So, a little bit tired, and hopefully I won't make very many mistakes. And the length of A we found to be this 15.26. So, my angle B is the inverse sine of this ratio if I take that denominator times that numerator. And divided by 15.26. Alright. Don't forget to close that parenthesis. Then I'm going to divide this by 15.26, and I'm getting 19.73 degrees. Yep, 73 degrees. All right. Now, I need to find the measure of angle C, and that's easier because I already have A and now I have B, and the three angles have to add up to 180. Alright, so we're done here with this problem number 3 because they gave us 3 pieces of information. We found 3 pieces of information. They gave us the measure of angle A. We found the measure of angle B. We found the measure of angle C. They gave us 2 of the 3 lengths. They gave us B and C, and that's how we started the problem, is that we found the length of A. So I hope that helps, and I'll talk to you later.